So now we're going to just do the last part of problem 12, part F. Okay, I've explained how to do the other parts in a Panopto video that's already in this module. So what we're doing here is part F, and it says there's a 5% chance that the mean reading speed of a random sample of 20 second grade students will exceed what value? Essentially what we're trying to do is set up the normal distribution for this problem. It has a mean of 91 and a standard deviation of 10. Okay, but now we're looking at samples, so the standard deviation will be modified. The standard deviation will be 10 divided by the square root of 20, because that's the sample size we're looking at. And they want to know what value on the x-axis will create a mark or a threshold so that the area to the right, because they're using the word exceeds, all right, exceeds greater than or equal, all right? And so we want this red area to be 5%. We want to know what value on the x-axis causes that. It's really easy. You set your mean to be 91. You set your standard deviation to be 10 divided by the square root of the sample size, which is 20. Okay. Then you set this 0.05. Okay, it has to be greater than or equal because we're doing exceeds. You hit compute and you get your answer. Notice the 94.68, 94.68. Done with that. So now let's go to problem 13. We're still using the normal calculator. So we have a distribution whose distribution is unknown. Do you see that right there? Unknown. And so we need a sample size greater or equal to 30. Our records indicate that the mean for this distribution is 21.3 and the standard deviation is 4.7. All right. So part A, it's just talking about sample size. Notice because the original parent population's distribution is unknown, we need our sample size to be greater or equal to 30 in order for the distribution of the x bars to be normal. Okay. Then down in part B, what's the probability the random sample of 35 oil changes results in a sample mean in x bar less than 20. So we come down here, change that to less than or equal. We set our mean to be, what was that, 21.3. We set our standard deviation to be 4.7 divided by the square root SQRT 35. And less than 20, so we say just the 20 here. Compute. Notice we get our 0.0509. Okay. Below, this is a little bit confusing, but all we want to know is what value on the x-axis in this scenario will result in a left tail equaling 10%. Okay, do you see the 10% right here? Okay, what value? Okay, our sample size is still 35. Okay, so what we do is everything's the same. Everything's the same except we just put 0.10. This is a lot like part F in problem 12, and we compute. And do you see how we have the 20.28? Actually 20.3 rounded to one decimal place, and that's it. Done.